Hello. So welcome to this talk. My name is Will Bolton. I'll be with you for the next 15 minutes or so. So this talk is called What to Do When Third-Party Data Does Not Match the Boundary of Your Site, or How I Learned to Stop Worrying and Love the Cookie Cutter. Who doesn't love ripping off Stanley Kubrick? So this is a general talk for a general audience. So we're not assuming any prior knowledge, and just to kind of give you an idea of what's going to come. So my background, very briefly, I'm a DevOps engineer at UKCEH, one of the eLTER institutions. And I've been involved with the eLTER plus Work Package 11 work, piloting services. And I've been the lead developer of the cookie cutter pilot, which is what I'll kind of introduce today. So the way the talk's going to work is that we'll just give a little bit of exposition on some problems that need solving. You know, why are we doing this in the first place? What's it for? We'll kind of describe a solution at a kind of theoretical level to have how we can go about dealing with these problems, and then give a quick overview of the pilot implementation. So we won't be looking at the implementation itself, the pilot tool, that will come in a later talk. So keep an eye out for that if that's what you're looking for. Okay, on with the talk. So I borrowed this slide from my colleague Jan Dick. She has a talk on the eLTER YouTube channel called eLTER and the Systematic Collection of Socio-Ecological Variables, which gives you a lot more background. But for the purposes of today, we'll kind of give a brief summary of why we're introducing this cookie cutting tool. So with eLTER, of course, we have a lot of site-based research, but briefly, there's a lot of other types of data that can't be gathered directly at an eLTER site. So this includes lots of types of data like legacy data, remote sensing data, national statistics, which can't actually be collected at the site, but which we do want to integrate because they help enhance all of the data that can be gathered at a site. And in some cases are things that would otherwise not be possible. So they help broaden the depth and the scope of the site-based research that we're doing. It's not an easy thing. We can't just say, here's some extra data and throw it with all site data. But if we could easily integrate all of this data, and if we could deliver that ability to integrate extra data centrally, it will save everybody a lot of time and resources as well. So when we're talking about other types of data, for today, we're just going to think about two types of data. So the first category is spatial data, such as this Copernicus land cover data. So in this diagram or plot, you can see an example from the Copernicus service where we have land cover data for the whole of Europe. The greener areas are more heavily forested, yellow going into red areas are less forested. And where this kind of data corresponds exactly, we have data about the Earth's surface, or a geographical region, in a sort of a grid of numbers, something like this. So spatial data, raster data, gridded data, there's a few words for it. This is the first type we're going to consider. The second type is tabular data, which is mainly in CSV or Excel files. And we've got another example of that here. So this is some EU statistical data. So each column in this spreadsheet is a year, and each row is that year's, those years' data on employment statistics, but it's broken down by region. So each of those rows corresponds to one of the NUTS statistical regions. And of course, because we know that each of these rows corresponds to a statistical region, there's an implicit spatial aspect to this element. Even though the spreadsheet itself is just a table of numbers, we can interpret this data spatially in a way. And both of these types of data need integrating in different ways. And that is the cookie cutting aspect of this data integration. Because we always have a problem when we're looking at these types of data, in that most of the time, unless you're extremely lucky, the data that you're trying to integrate won't match the spatial area of your site. So if we take a look at the Cairngorms National Park in Scotland as one of the examples, we can see this in these two diagrams, with these two data types that we've mentioned. On the left-hand side, we have a plot of some air pollution data for the whole of the UK. So obviously, we do have data for the Cairngorms within that data set, because we can see, we plotted it in red, all of that red area has values. It's not white, it's not blank. But we also have all of this other data that we might not be interested in as a site. So if you imagine that this was a sheet of dough, and we were making cookies, obviously it would be nice if we had a Cairngorms shaped cookie cutter that we could press in and just take out that section of the data, hence the name, the cookie cutter. And that's what we would like to do ideally with the spatial data types. It's similar with the statistical data as well. So on the right-hand side, we have a plot of the Cairngorms again, outlined in black. And we can see that underneath it, there's a plot of Scottish counties. And so if we had some statistical data that was grouped by county, well, we could see that there are 1, 2, 3, 4, 5 counties that fall within the Cairngorms. So what we might want to do is just take the data for those 5 counties and then work with that. But obviously you can see here on the map that it's not quite enough. Most of these counties, only a small part of their area fits within the Cairngorms. So it's, you know, if we had the population data for all of those 5 counties, then clearly we can't just add those up to get the result for the Cairngorms, because it doesn't account for all of these areas that sit outside the park. So we need to kind of add some extra info to the data as well before it's really useful. And there are several strategies that we can use to do this. The simplest strategy is just to say, okay, half of the area of County A sits within the park, half of it sits outside of the park. So here is the number of half, that's how much is contained by the site. Do with it whatever you want to do. And do that for all of the different counties, so that some of them maybe only a tenth is contained, some of them maybe fully contained. But calculating the area, the ratio of how much is in versus how much is out of the park, is the most basic solution, and it's the one that's currently implemented. We'll talk about later. But of course, there are lots of other different strategies as well. We can have binary yes/no's based off whether centroids of area or population sit within or without the park. We can also look at comparing things like known population densities between the park and the counties. There's several different strategies, but we need to have a strategy, and we need something that's going to do this for us, which is where the cookie cutter fits in. So just a brief word before we look at roughly how this has been dealt with as well, is the difference between national data and international data, or European data. So here we have spatial data for the UK, again looking at the Cairngorms. So on the left-hand side, we can see the UK's own land cover map product, which is land cover data for the whole country, versus the right-hand side, where we can see that's Korean land cover data from earlier and the kind of zoomed in version for the UK. So with the spatial data, really all that's different is the extent of the overall data sets. And since we're throwing away the rest of the data anyway, we're just taking what's in the site. With the spatial data, it doesn't really make much difference whether it's national or international data. However, with the statistical data, it is different. So there's screenshots of several different statistical portals. On the left, we have the Slovakian national data portal, and at the bottom, we have the Scottish national data portal. So the Scottish national data is grouped at the national level, as you'd expect. So the Scottish government chooses to use things called data zones, and also things like intermediate zones and various other kind of groupings of data that all of its statistics sit with. This is obviously different to the European data, where It's all internationally kind of harmonized across the not statistical areas. But in general, the national data sets will always be grouped differently to the European data sets. So we have to know the geographies of each of those national kind of statistical zones before we can kind of successfully cookie cut any national statistics for the different sites. It's Europe. So those are the kind of the two ideas that we had in mind, and we do already have a pilot implementation of those. So the pilot cookie cutting tool is already available for anybody in eLTER to look at and play with in the UKCEH Data Labs platform. So this code can be run anywhere, and I'll include a link to the code at the end of the talk. But for now, this is where it's already available, doesn't need any setup. And this is a screenshot of roughly how it looks. So it's all done via a web-based user interface, which you can see. We choose a lot of options on the left. We get our data back on the right, and we can download it and do whatever we want to do after that. So the main things that we've done, once we've supplied some data, we just tell it which eLTER site we're interested in. And at the minute, all eLTER sites are supported because we have a link with the DIMES platform. And for the statistical data, we also say which zones our statistical data is grouped by. And currently only Scottish national statistics are supported, but European-wide statistics are supported across the board. So the reason it's in this Data Labs platform is to help it. This is only one part of the process of integrating extra data. Of course, we have to fetch data, store it. But because it's already in our infrastructure, it'll be easy to integrate this with other RI components over time. So this is the kind of output that we get. So taking that grassland data from Karine, we can see a map of the Bryla Islands site in Romania. And on the right-hand side, we can see, you'll recognize the shape of the park. This is just that data that falls within the Bryla Islands platform, ready to be processed in some other way. Similarly, we have, for some statistical data, we've taken some Eurostat population density data. Again, we have a map of the eLTER platform Eisenwurzeln. On the left, you can recognize that in the plot on the right-hand side. So this is just a plot of the eLTER site. And you can see the NUTS regions overlaid on that plot as well, or plotted in different colors depending on what data is present. And at the bottom, we've got a kind of a brief, a truncated view of the kind of data that comes out. So we can see that for each of the zones that falls within the LTSER platform, we have the ID of that zone and the friendly name. The area ratio column here gives you that extra information we talked about earlier. So in this case, this is the area of how much of the zone falls within the park versus how much falls without. Of course, these values all range from 0 to 1. And we have no zeros because those have been filtered out of the data set. But in future, we'll possibly implement some of these alternative strategies, these yes/no strategies, or whatever else. But anyway, that kind of extra metadata about the kind of how much of an overlap there is, that is added into the data set. And from that point onwards, 2018, ... these are all of the columns as they were in the raw data, ready to be processed. So that's it for this talk. Hopefully you understand what the cookie cutter is doing now and how it fits into the broader picture of the RI. As promised, there are a few links here. So the code for the tool and written documentation. So this includes user guides, installation guides, and everything else, can be found at the following GitHub link, which is part of the eLTER RI's GitHub platform. The Data Labs platform that I mentioned, this is already up and running in. If you'd like to use it, there's a lot more that Data Labs does. but those can be found at this address as well, datalabs.ceh.ac.uk. So if you are interested in having a look at the tool, then sign up for an account at that link. And once you have an account, drop me an email. My email address is there, and I'll grant you access to the eLTER project. And the next final resource will be the next talk as well. So we've gone through a kind of a high-level overview of why the cookie cutter, but next talk that we do will be more of an in-depth look at the nuts and bolts of how it actually works. So we'll go through a few example data sets. And that is it. So thank you very much for joining us today, and I hope you have a great day.